Good day, ladies and gentlemen. Today we're going to have a brief video over the circumference of a circle, and we're going to end up with talking about arc lengths of a circle. So let us start first talking about the circumference of a circle. Well, it was discovered probably 400 years before Christ that if you took the circumference of any circle, and we're going to abbreviate the circumference CIR. If you took the circumference of any circle and divided by its diameter, and the diameter is a chord that goes through the center of a circle. These are just review of some basic geometry terms that we learned back in geometry class. But if you took the circumference, and the circumference is the distance around a circle, it's the distance around a circle, took the circumference divided by the diameter, it came out to the same unusual number. And the Greeks discovered this, and then I'm not quite sure, maybe 16th century, 17th century, they decided to name this number pi. And that's going to be this irrational number somewhere between 3 and 3.5 on the number line. So pi is an irrational real number. This was discovered, like I said, a long time ago. And we know the diameter is equal to 2 times the radius. So this distance here is the radius, 2 times the radius is the diameter. And if I look at the circumference, and we're just going to let the circumference now be c divided by 2r, which is equal to pi, because of this formula that this relationship that they found out many years ago. And we know that the diameter is 2r, and if we solve for the circumference there, we're just going to multiply both sides by 2r. So this is going to be our formula, 2 pi r. And that's the formula, that's the age-old formula for the circumference of a circle. 2 times this irrational number pi times the radius. And this is the formula that we're going to use to find the distance around a circle, which we define to be the circumference. So let's formally talk about the circumference of a circle. We know that the circumference is 2 pi r. Okay? And this is the formula for the circumference of a circle. So we can talk about if r is equal to, I don't know, let's say 5, then the distance around the circle, the circumference is simply going to be 2 pi r, which is, in this case, r is 5. So the circumference is going to be 2 pi times 5, which is 10 pi. And for this trigonometry class, I know in geometry, we use the fact that pi is approximately 3.14. We are going, some of the assignment problems may have you estimate pi at 3.14, but for our study in trigonometry, we are going to want to leave all of our answers in pi. So the circumference of a circle whose radius is 5 is simply going to be 10 pi. Let's do a few more examples here. So, well, here's the example that I just did right here. If r is 5, their circumference is 10 pi. And if r is 7, it's easy enough. Their circumference is going to be 2 times 7 times 5, 14 pi. And if the radius is only 1, then the circumference is 2 pi. And I will point out we're going to use this a lot in trigonometry. This fact right here. We're going to use this a lot in the coming weeks. The fact that the circumference of a circle with radius 1 unit is going to be 2 pi. This is going to be an important information in our study of trigonometry. So again, just to prepare you for some assignment problems. So if the circumference we know is 2 pi r, and if we're given that the circumference is 14.4 and we want to find the radius, again, we're simply going to use the formula. Circumference is 2 pi r. We're going to substitute 14.4 into the circumference. And so now we have 14.4 is 2 pi r. Divide both sides by 2 pi. And we get the radius is 14.4 divided by 2 pi. And again, this answer would be it might be nice to make it 7.2 over pi, but we can estimate this, and I will use my calculator, and my calculator has pi to multiple digits. So I'm going to take 14.4 and divide it by 2 times pi on my calculator, and that's going to come up to 2.292, and that's the estimation of the radius there. There's going to be a couple problems. This particular topic isn't going to be nice to know, I guess, manipulating this formula. Not too important for where we're going in the study of trigonometry. However, what is going to be important in our study of trigonometry is the arc length in a circle. So what I'm talking about is this length right here. We're going to call this arc BF. This is arc BF. Arc BF. And you could call it arc FB if you want. But the way we denote arc BF is we just write the letters BF with a little arc on top of it. You may or may not remember that from your study of geometry. But what our goal in this particular portion of the video is to find the length of this arc BF. And in order to do that, we need to review this topic of the central angle. And the central angle of a circle is an angle whose vertex is the center of the circle. So A is the center of the circle, and whose rays from that angle, the rays of that angle, pass through the circle. So this is called a central angle. The vertex of the angle is the center of the circle. So we're going to talk about angle BAF. And what is interesting is the measure of this angle BAF is equal to the measure of arc BF. So the measure of arc BF is different than the length of arc BF. So what we have here is that the measure of arc BF is equal to the measure of angle BAF. And let me demonstrate that. Let me come down here and get another, and I'm going to demonstrate that, the fact that, so I'm going to take us 2 circles here, and I'm going to make those circles so that they have the same, so they're going to be concentric circles here. So these circles both have the same center. And if I look at this ray here, let me go this ray here, and out here, and this ray here. So this angle right here is a central angle. And note that these circles certainly have different diameters and different radii. But this central angle right here, if I let that guy be X and this guy be Y, and we'll just let the center be A, and this guy be, I don't know, N, and this guy is M. Note here that the measure of angle XAY is equal to the measure of angle NAM. So they're the same angle, but note here that this length here is way shorter than this length. And the object of this portion of the video is to come up with a formula to find the length of those. So if I go back to the slide that I was on, and I just did this demonstration to demonstrate that central angles is not the measure of the central angle, is not the length of the arc. So we're back here to this guy right here. So we know the measure of arc BF is equal to the measure of the central angle BAF. Okay, BAF. The length, what we want is the length of BF. Well, the length of BF, true or false, is going to be a portion of the circumference. It is a portion of the circumference. Well, what portion is it? Here's what portion it is. And this is going to be the formula for the length of a circle, length of an arc. So the length of BF is going to be the measure of arc BF divided by 360. That's the portion times the circumference, which is 2 pi r. I don't know what this little rascal is here doing here. I'm going to have to get rid of him. Get rid of that dude. So this is the formula that we're going to use to find the length of arc BF. It's going to be the measure of arc BF divided by 360 degrees. These are both going to be degrees times the circumference. So you might jot that formula down. So let's use that formula now. Okay, here we go. And so here I have a specific circle with center A and R is 3. And I want the length of BF. Well, the length of BF is going to be the measure of BF divided by 360 times the circumference, which is 2 pi r. R is 3, so it's going to be the measure of BF. Well, let's look at what is the measure of arc BF. Well, it's going to be the measure of this angle, and I have the measure of the angle is 90 degrees. So this is going to be an easy one to figure out. So the measure of arc BF is going to be 90 divided by 360 times r is 3, so 6 pi. And we know 90 divided by 60 is 1/4. And so it's going to be 6/4 pi. And we certainly can write that as 3/2 pi. And that makes sense that since 90 over 360 is going to be 1/4 of, 90 over 360 is 1/4. And isn't it true that if I go all the way around a circle, so let me do this a minute, pardon me, let me do this a minute. We're going to be doing this a lot in our study. If I take this and go all the way around the circle, that's going to be 360 degrees. If I go 90, I've only gone 1/4. So this length here, then it makes sense that this is going to be 1/4 of the circumference. And it is 1/4 of the circumference, which is 3/2 pi. And how this rascal got in here, I have no idea. These guys just end up all over the place. Let me get rid of that, see if I can. Well, I'm just going to leave him there. Heck with him. Okay? So let's find the arc length of another portion right here. So here we go. I have a circle with center A, and the measure of angle FAE is 120 degrees. So that's what we're going. This measure right here is 120 degrees. The radius is 4. So this length here, this length is going to be 120 divided by 360 times 2 pi r. And we see that r is 4, so 120 over 360 is 1/3 times 2 pi times 4. So this is going to be 8 pi. So it looks like it's going to be 8 pi over 3. And that's the length of arc FE. So this video has been a little bit of review of some geometry that you did probably 2 or 3 years ago, which is going to be very important for our study of trigonometry. Catch you soon.